The last problem I want to show you real quick is an example of the geometric problems, which are the ones that people seem to mind the most, but actually are probably the easiest ones because there's not a whole lot that can make the equations complicated, as opposed to some of the other ones that can have logs and square roots and all kinds of awful things in them. The first step here is to draw a picture. We're trying to build a rectangular fence. We want to label the dimensions because that's what we're trying to find. We're trying to find the dimensions, so the dimensions ought to have variable names. We want to locate in the statement of the problem what it is we're trying to maximize or minimize. So we have to here think about what this means. Most economical means that we're trying to minimize cost. Okay? So minimizing cost is going to be our goal. So in terms of working the problem, that means that we need a cost function. We need a function that gives us cost, because the idea of these max-min problems is that we're able to maximize or minimize the output of a function. So if we're trying to minimize cost, we need a function whose output is cost. We need an equation that says cost equals something. So we're going to answer this in terms of the variables. Let's read the problem now. The fence along three sides is made of a material that costs $4 per foot. So let's just say that's these three sides. So if this costs $4 per foot, then the total cost of this side is $4 times x. And the same thing for this side. This side costs $4 times x. This side also costs $4 per foot, but there's not x feet on this side, there's y feet. So this side costs $4 times y. And the final side, it tells us that the fourth side costs $12 a foot. So this side that did not cost $4 a foot costs $12 a foot. So the total cost on this side would be 12 times y. So what we're doing here is taking the cost of the material per foot times the number of feet. So the total cost here is going to be 4x plus 4y plus 4x plus 12y. So just the sum of those costs. 4x, 4y, 4x, and 12y. And of course I should simplify that. That's crazy to leave it like that. That's 8x plus 16y. Now the only problem with that is that it uses two variables. And we don't, at this point in our course, have a way of working with problems with two variables. So I need to turn this into a function with one variable. So I need this to be a cost function that has just one variable in it. And so that means I need to eliminate one of the variables. Well, if I can help it, I'll eliminate the y because I like having x for my variable. Well, how do I do that? Well, there's got to be something else given to it. It can't be that the size could just be anything. There's got to be some kind of constraint. And in this case, the constraint is just a piece of information that we haven't used yet. The constraint is just a piece of information that we haven't used yet. So go back fishing through the problem. There is one thing that constrains the fence that we haven't used yet. The fence has to enclose a rectangular area of 450 feet. That's the piece of information that makes us not just be able to use just anything we want at all for x and y. So what does that mean in terms of our picture? Well, area is base times height, so it means that x times y has to be 450. So perhaps, x might be 15 and y could be 30. 15 by 30 would have a 450 square foot area. So as long as the x times y equals 450, everything's okay. Well, knowing something like that allows us to eliminate the variable y. Because if you want to get rid of a variable, then all you have to do is take this equation and solve for the variable you're trying to eliminate. So if I take the equation I have circled here and solve for y, it says y equals 450 over x. And so the y in this equation can just be replaced with 450 over x. So cost then is 8x plus 16, not 16 times y, but rather 16 times 450 over x. And so this then is a cost function that only has one variable in it. So now we're ready to find we're trying to do the max-min problem. So to find where this is maximized or minimized, I first need to know the critical values. So to find critical values, I find the derivative. The derivative of 8x is 8. It would help here to know that 16 times 450 is 7,200. So this term right here is really 7,200 times x to the minus 1. We think of that 1 over x as x to the minus 1 so that we can use our power rule. So the derivative there would be negative 7,200 times x to the minus 2. And so we're going to have to do some algebra with this, so it makes sense to simplify it. We'll say that's 8 minus 7,200 over x squared. So instead of having the negative exponent, we'd rather that look like a fraction if we have to do algebra with it. So remember, the idea for critical values is to find that derivative, set it equal to 0, and solve for x. So if I do that, I'll get 8 is 7,200 x squared, multiplying through by x squared, or if you like thinking about cross multiplying, we'd have 8x squared equals 7,200, which means that x squared is 900, which means that x is plus or minus 30. Now notice that it doesn't make sense to have minus 30 for x because x actually represents the length of a piece of fence. So the only value that actually makes sense here is x equals 30. And so that's the only critical value that we have. So if there is a absolute minimum, then it has to be at x equals 30. We could check, it uses that theorem in the book again. If I checked, just think about the second derivative, that's an easy enough thing to peek at. The second derivative here is going to be positive 14,400. Sorry, I lost track of my zeros. X to the minus 3. And so notice that this is always positive. Because remember, the x can't be a negative number. The x has to be a number greater than 0 because it represents an amount of fence. So the second derivative is always positive. That means that c of x, the cost function that we've created, is always concave up. So if you have a function that's always concave up and it only has one critical value, well then that has to be the absolute minimum. So the minimum value for x is 30. So 30 feet for x. And remember, this equation here tells us how to find y if we know x. So y is 450 over x. So that means y is 15 feet. That's the only way we're going to have this dimension be 30 feet and the other direction be, and the total area be 450 feet. So the short side is 15 feet and the long side is 30 feet.